Hi, everybody. We're going to look at the difference between recursive and explicit formulas for sequences. Luckily, I did a little preview and it's really, really easy. I'm glad I did the preview. I'm going to explain the first one and then I'm going to go fairly quickly. The thing about a recursive formula is that it involves an a to some value. For example, this a to the n is defined in terms of some other a to the n. And what they're saying is that in order to get this value, this new term, you have to take one of the previous terms. And this is a previous term right here. And so is this one. Any formula that involves previous terms is called recursive. And so if there are only n's involved, like a to the n is equal to 3n minus 5, this would give you what's called an arithmetic sequence. And if we started with 1, we would get -2. And then 2 would give us 1, because 6 minus 5 is 1. And 3 would give us 4, and so on. And it would go up 3 every time, forever and ever. And there's the next term doesn't have anything to do with the other terms, and that's called explicit. So in this case, we're talking about recursive because it's got two of its former terms that are defining the new term. So it's recursive, and I think you're going to find this is going to go very quickly. This one has no a to the n terms in it, so it's explicit. This one has no a to the n terms in it, so it's explicit. This one has a single a to the n term in it. Some people say, well, it has an n too, but the reason is it's recursive because you have to know what came before in order to get what comes next. This one, of course, is recursive. It's using former terms. That's all that we care about. This one is recursive. You have to have the term that happened before. Oh, this is going to take a while. I didn't expect it to be so fast. Okay, recursive because we have two former terms defining the new term. This one is explicit because the only thing involved is an n value. This one is only an n value. There is no a to the n plus 1. Of course, that wouldn't work anyway, but that is explicit. This one is recursive because it's involving past terms. This one is explicit because it only has n's. Even though it's a big one, this is called a third degree polynomial. It has 4 terms. Its highest exponent is a 3, lots of stuff going on, but it's definitely explicit. This one has a former term, so it's recursive. This one has no former terms. I know you're thinking that little n matters, but that n is an exponent and it is explicit. It's a geometric sequence, by the way. This one is definitely recursive. We've got 3 former terms that are defining the new one. You have to know what the last 3 were. This one has 2 former terms involved, recursive. This one has 1 former term, but it still counts as recursive. This one has no former terms. And by the way, this is a geometric sequence, but it's an alternating geometric sequence because the negative is going to alternate. It's going to alternate between positive and negative numbers. And it is explicit. Don't be afraid that n minus 2 or n minus 1. That isn't what counts. It's the fact that there's only n's involved and there are no a to the n's involved. That's explicit. And this one has two different values in it from before. So this is recursive. And we're getting there, almost done. Actually took longer than I expected. All right, this one is explicit. This one is explicit, even though it has an ln in it. That stands for natural log. I'm surprised it's not in parentheses. Oh, well, explicit. This one is recursive because it has former terms that are defining the new one. This one is explicit, even though it's an ln, natural log. This one is explicit. It's a polynomial. This one is recursive because we're using 3 former terms in order to get the new one. And this one has 2 former terms, this one and that one. We're almost done. This one has 2 former terms, so it's recursive. And our last one is recursive because it has a former term that is defining the new one. And I hope you guys will get it. It's a pretty easy one. I'm sure you didn't go this far. So there you have it. Hope to see you back again. Bye-bye.